get back into yesterday's sum that there wasn't time and then we're starting to make a mess of it. If you see something like this, it doesn't resemble sin, cos, cos, sin, which is the sin compound angle, or cos, cos, sin, sin, which is the cos compound angle. So you have to make a decision. I can't remember what we did yesterday. Shall we start from the start? Yes. And so maybe we would have said sin, cos. If I do that, I'm going to change the sin. I'll change the sin. 65. And then make this cos. And now you have to go find out what it is. Is it 30?
20.
Is it 35 to get to 90?
Yes.
Sure? Yes. Okay. If we do that, then we should make this one be sin 35. Sin cos, cos sin. And there it is. So that sin 35 was there. I'm just putting it at the back. But then this one has to be cos 65, and it is. Now that's one of the ways. I think yesterday we were speaking about 3 or 4 different ones all at once. You have to make a choice. If your decision was to go cos cos, then it had to look like this one with a sin sin. But then also, please, it's important that you put them the other way around like I did, so you can see that it's sin cos cos sin, 65 35, 65 35, so that you can better organize yourself when you're writing it into the compound angle, which would then be compound angle of sin, and the 2 angles, and it's always just 2. These compound angles are all about being 2 angles, and 2 angles are 65 and 35. But if it was minus and it's the sin one, it stays a minus. If it was a cos one, the sign changes. So then this became sin, which was just a off. Please go and have a look if you can change it into cos cos, sin sin, and it does get to the same one. If it did go to cos rule, it would have been cos 60. Has to work out to the same answer. So if you went for the cos compound angle, eventually it would have had to be cos of 60, because you know that sin 30 and cos 60 is the same because of cofunctions. Alright, then that was the end of that. I would have liked to have started today freshly, but here we go. For the double angle formulas. Again, it's on your formula sheet. Please, you must know that formula sheet. Find it there now for yourself. And then know that if you get that paper, you'll be able to pinpoint exactly where it is immediately. So, sin of a double angle. Now the double is there because you're looking at a 2a, but I want you not to think that way because it's not always going to have a 2 there. The major thing is when you go to the formula or the identity, it says 2 times. Now that 2 is going to always be a 2. But then it goes sin of a cos of a. Now, luckily you don't have to know where it comes from. That's a formula. So you don't go and say, oh, what happened there now? Did the 2 go stand in the front and then cos just popped in for a visit or what? This is a formula that you don't have to know where it comes from, but this is the double angle formula. So from the start hammering it into your own head that if this is like 80, then these angles would have been 40. So it doesn't have to be 2 times something. If you see 80 here, you could make it 40 and 40. Yeah, and it's going to be strange in the beginning. You're going to have to practice quite a lot to know that this is equal to that. Not because of you doing something, it's a formula. Then you get to the cos one. Now for the cos one, I left space here because there's not just only one. There's 3 different formulas. The first one is that cos square of A, the angle was double of A, or 2A, and then this one was just cos of a single angle. And then sin of the single angle. This reminds you of something, doesn't it? Identity. Identity that says sin square plus cos square is 1, but it's not. The formula has a negative, so it's not. Is it still equal to 1 if I say sin square plus cos square of the same angle? Absolutely, it's not going to change. So somewhere in the sum that'll still pop out. You've got to know that that is still 1. Very important that if it's sin squared plus cos squared, has to be the same angle. You know that from previous experience. But now this is nothing to do with that identity. It's a different identity. It's a double angle identity where the double angle of say 80 again became 40 here and 40 there. It's nothing to do with sin squared plus cos squared. Can I not change it into sin squared plus cos squared? No. If you time this whole thing with a negative by taking out a common factor, this will be negative and this will be positive. You're not going to get to sin squared plus cos squared. This is a different identity. Right, the other two that there are is 2 cos squared minus 1. And now whether you know it or your because it's all there on your formula sheet, all three of these that I'm going to write now. But to get to actually where they did get it from, it means that you took cos squared minus the sin squared. And how did you get to just something with cos? What do you think? This sin must change to? Can you just change sin into cos? You can, but then it's going to be 90 minus. That's not fitting my profile. You can change sin into cos, but it's 90 minus the angle then. That doesn't fit this picture. So you can change sin square into what? Still using the sin square plus cos square that is equal to 1. So if I want to change this sin square, I can change it into 1 minus cos square. What identity is that? That's grade 11. That's the square identity that you've been taught long time ago. Can you see where they got to their answer? So you would have cos square minus 1, because remember that was minus the whole thing, so it's still minus the whole thing, making this up, plus, and then that becomes 2 cos squared minus 1. That's just to show you where they got it from. Once you've got the one, you can get the others. So then the other one that they could have done, instead of changing sin square into 1 minus cos square, let's change cos square into, is that true? But there was already a minus sin square there as well. So we use the square identity again from grade 11, and this becomes sin square. So 1 minus 2 sin square. Now just like last year, you were taught, please don't think that if I say sin plus cos, it's equal to what? 1. Or even, no, it's not a square, so maybe it's square root of 1 or half of 1. It's either right or it's wrong. If it doesn't have squares, that's it. You can't do anything to it. So the same thing for these formulas. They only work if there's a square. But take it back to the double angle, then there's no more square. So you don't ask yourself, what happened? Where does the sin pop out from? Where does the 2 go? How come there's no squares? It's a formula. It's a rule. You've got to know it. We don't look at how we came about to this. You've got to know that those are the formulas. Let's look at some examples. Number 1A on page 134 said, take this and please elaborate or make it bigger using double angles. Using double angles. So if I say sin to theta, what are you going to write? 2 What's in between here? Times. It's all multiplication. And the 2 will never be anything else but a 2. But this could have maybe been, let's say 3. Does that mean anything? Not yet. There has to be a 2 in the front. Then you could make this one angle now again by saying it's sin of 6. Because now this is the single angle going to double angle, so it doesn't quite compute. But whatever's there, this should be double that. And where's the 2 gone? It's part of the formula. Are you with me? You get lots of this stuff and you're going to say, but man, where's the cos now? You are looking at a formula. 2 sin cos of one angle will now be double of sin, double angle. Are you with me? You have to practice this a lot because it's freaky. You don't see it happening, you must know it. Second question also said, please use double angles to do sin 60. Who's crazy enough to do that? Sin 60 has always been root 2 over 3. Sorry, I'm lying. Root 3 over 2. Are you with me? But listen to the question because we are practicing this new stuff. They're saying use double angles. So what do? We use double angles. It's definitely a sin double angle, that formula, not cos. When we get to the causes, you're going to have a choice. When you get to sums, there's going to be better choices and worse choices. Because you're always going to have a choice of all three of them. And you're going to have to practice a lot to choose the correct one. So in this case, it'll be 2 times what? We're doing exactly what we did there. 2 sin something, cos something. What's the something? 30. Are you with me? Yes. Man, where does it come from? No, we passed that now. It's a formula. Would we be able to simplify that? Okay, so we'll say 2 times sin 30 is a half. Cos 30 is root 3 over 2. And guess what that answer is? Because root 2's are going to cancel out. Which is exactly what we got. Man, this is a stupid sum. No, this is just practice to write it from one form to the other. But it's still going to be the same answer. So if the question just said to me, use the double angle formulas to elaborate, then that was it. You've done it. I don't want the answer, otherwise you could have given the answer over there with using of your special angles. Right. Alright, now the question would be, what? If I gave you this, what? Do you see that it's a double angle? Now normally this is inside of another question. And you're seeing that I'm searching for angles 150, 30, 20, 50, whatever. But this one now said, please make this an expression with one trig ratio. How many trig ratios are there at that moment? There's 2, so make it 1. How do I do that? Oh, I see the identity. Here's which one. So again, you can go from there to there, or there to there. So this, we put it all together. Elaborated it. Now it's elaborated, we're putting it all together. So if you see cos square minus sin square, what must you do? It becomes a cos of double the angle, which was 75, so it's going to be 150. And in the beginning, if you want to write 2 times 75, it's fine. But the quicker you can know it's double that angle, so it's 150, that's fine. Would we stop there in a sum? What would we do with it? We would reduce it to 180 minus. But listen carefully what this question said. This question said, make it 1 trig ratio. Done. Because it's just practicing this whole new thing into action. But I would have said, minus cos 30. How come? 180 minus 30. Poof. But cos in the second quadrant is negative. And even further, because that's now special angle, I would write. Are you with me? Again, I would have stopped there if they said write as 1. That's it. 1 more. Done. You don't have to go on. For now, it's just practice. Right, for this one, what's wrong?
The sin is minus.
It's the other way around, so? Just take the minus outside. Is she right? Can I get rid of the minus?
No.
You cannot just say, I don't like the minus, I want it to be cos squared minus sin squared, because you're on the right track because you know that that's the formula. Not sin squared minus cos squared. It's cos squared minus sin squared, but that is not equal. Now it's equal. But you cannot get rid of the minus because this is not an equation. You can take it out. But then what happens to this minus? It just stands there. But this is still going to be a cos double angle. Cos of double that angle, which is 50, and now it's not even a special angle, so that's it. I have made this one trigonometric ratio, and I can't carry on because it's not a special one. Can you work it out on the calculator? Yes. But then they would have said round off your answer to whatever. And then you could have just as well put that whole thing in your calculator and got the answer. But inside the sum, this would have been something that I needed to get to past 15. Maybe there was something over sin 30. So that they can cancel out sin 40. Are you with me? All the stuff that you already know is going to come into play. Okay.
Yes, ma'am.